Good afternoon, my name is Josep Mangas. I'm head of the Communication Networks Division at CTTC, and I'm work package leader of the Communication Dissemination and Exploitation of 5G-Transformer. So 5G-Transformer is about the transport network of 5G networks. So we often forget that 5G networks are not only about the run and the access and having higher download speeds, but there is also a network behind that needs to carry all this traffic. So 5G Transformer is about that. It's about moving from the rigid interconnection of networks at the transport level that we currently have and move to a software-defined and virtualized network that can carry all the traffic of all the different verticals and adapt to their requirements. So for that, the key concept here is that of network slicing. So we will slice all the underlying transport infrastructure, which may be heterogeneous, and show it in a homogeneous way so that we can create slices that adapt to the requirements of the verticals. And we do that with three architectural components. On top of it is the vertical slicer, which is the building block interacting with the vertical and offering a vertical service catalog, which the vertical will request. After that, this vertical request will be translated into an NFV network service that will be handled by the service orchestrator, which is the building block in charge of getting the requirements from the vertical, requesting the underlying platform, which is called the MTP, which is the third building block of the architecture, requesting the MTP, what are the available resources, topologies, and so on, and doing the mapping between the requirements of the vertical and the available resources. And once this is done, the service orchestrator will be in charge of deploying all the service end-to-end and having a control of all that. So this was it for the what 5G Transformer is about. And what is this demo about? So this demo is about adapting dynamically to the needs of a vertical, which in this case is an automotive use case, an automotive vertical. It's about an extended vehicle sensing, meaning that in addition to the sensors that you have onboarded in the car, you will have additional external sensors that will complement those ones, so that eventually the car will be able to decide what to do based on this additional information. For example, in this case, it's about knowing, even if there are obstacles, if there is some risk of colliding with other verticals, with other vehicles, sorry. So this demo will show how we first can dynamically instantiate the service, the extended vehicle sensing, and then once we reach a certain threshold of CPU, the system will detect that and will automatically trigger the deployment of a new extended vehicle sensing that will split the load that the original service was carrying. So, and all this is automatically handled by the 5G Transformer platform that I described before. This is the scenario of the demo. It is distributed between two sides. This booth, this is the left-hand side of the figure, and the CTTC lab, so in Barcelona. Then at the CTTC 5G lab, what we have is the full platform. So this means the vertical slicer, the service orchestrator, including the open source Mano, the MTP platform dealing with the resources, and the monitoring platform. So vertical slicer and monitoring platform were developed by Nextworks, and the SO and the MTP, in this case by CTTC. So this platform is connected through a VPN with this booth, And what we have in the booth is first the edge host, where we are deploying all the virtual machines that represent the BNFs of the service. This was prepared by Politecnico de Torino. And the open stack that acts as a beam that controls this edge host and the deployment of the virtual machines in this host. Additionally, we also have a RAN. In this case, that laptop over there together with this node represents the eNode B. This laptop together with this node represents the UE, and the cars are emulated. So we generate a trace of mobility of cars that are sent with the Sumo simulator. Then the other thing that we are doing is to connect remotely through this VPN to the graphical user interface of the platform. Then from this graphical user interface, the vertical, in this case the Fiat Research Center, will request the deployment of the service. We will do the processing at the platform level, and by interacting with the OpenStack that is running at this host, we will eventually deploy the extended virtual sensing service, the vehicle message database, which in this case is a cooperative information manager, storing all the messages received by all cars, and the warning message service, which will send the corresponding alert, the DEM messages to the cars in case there is some risk of collision. And also the virtual EPC, which is the core of the mobile network. And this is dynamically deployed and handled by the platform.
So here we have our use cases: 360 immersive telepresence, robotic control. So we have two different services we need to handle. The first one is 360 immersive video streaming. So it's very high quality, high definition, ultra broadband type of communications. And the other one is robotic control, which is ultra reliable and low latency. How are we going to handle these two kinds of services at the same time is by using the resources of two different projects. One is the 5G-Transformer, and the other one is 5G-Coral. We are, as InterDigital, we are involved in both these projects. So the first one, the 5G-Transformer, where we use the vertical slicer, which is the entry point in the communication. For example, vertical, as for example, a 360 provider, a supplier, will need to just input quality of service parameters and constraints in the vertical slicer, which is a GUI, is a dashboard. And once we have all these inputs processed by the vertical slicer will just send a request to the orchestrator, which is in the 5G Coral, it's called FOGO5, which is basically a FOGO5 is a fog computing platform, which we deploy all the computing between three different layers. Here we have the data center layer, processing in terms of graphic processing for the 360, compression, and segmentation. Then we have this machine, which is the edge layer, will handle part of the processing power. And finally, our fog computing module, which will just adjust the orientation from the user. So in this case, this is our goggles. Once the operator wears this goggles, this headset, he will be able to see what is streamed by the camera, and we can just adjust the orientation, which is processed by the fog node, and we can also reduce the bandwidth consumed by this processing, by this service.